These are what are called inscribed angles. These are not central angles. They are very different because the vertex is not on the center. That's why it's different. Basically, you could look at it this way. If the angle is named by 3 points, all 3 points are going to be on the circle. If you take a look at this very first one, we have point A is on the circle, point B is on the circle, and so is point C. Of those three, A, B, and C, of what you see there, which one's actually the vertex of this particular angle? B. And what's going to happen is it's on the circle. Remember, the central angle, I'll just kind of draw one in pretty quick, would look more like that, right? It would go through the center. That's not what we have here. What we have is what's called inscribed. And that's basically what it says up there. It says that these have to be chords, and are they? Yeah, those are chords of the circle, and that's how some people like to think of it, that it's chords instead of radii. Okay, so that may help you as well. So basically, that angle there that I've traced a few times is called the inscribed angle. And would you agree that that angle basically creates that arc? It tells you where to start and stop, right? And that's called, real big word for it, that's called the intercepted arc. You could kind of think of it as a football thing. Intercepted means they got in the way of the pass, and well, this kind of got in the way of the arc to keep going. Okay, that's kind of told it where to start and stop. Okay, and once again, I would probably make sure in this case to actually write ADC, because then you know which way to go. If I just told you AC, couldn't you technically go either way if you wanted to? And so that's why they were very specific. But normally when they talk about the intercepted arc, it'll be kind of inside the angle. Does that make sense how I said that? That it'll almost like it would eat that arc, okay? Or like it says here, the arc on the interior of the inscribed angle. So is there any question as to what an inscribed angle is? Or what the intercepted arc is, or where you would find it? So is it a central angle? No. Okay. Basically, if an angle is inscribed, then the measure of the angle equals blank the intercepted arc. So let's go back here. Remember, if I was to find this measure, let's say this was, and you don't have to write this down, but let's say this was, I don't know, that looks about like 150 degrees. If I asked you for that arc, you would tell me 150 degrees, right? Does this look like a 150 degree angle where I just put the red dot? More or less? Less. Anybody want to take a guess about how much less? 70's pretty close. Wrong way. How about 75? How would I come up with that number? It is divided by 2, or it is half, and that's exactly what this is. Here it says basically the measure of the angle equals half the intercepted arc. Okay, so in that case back here, this intercepted arc actually measured 150, and that would have been 75. Okay, now the central angle is going to match it every time, but the inscribed is going to be half. Okay, can you understand the difference between central and inscribed? Do you see it there? Okay, yes. Okay, the central angle. Okay, let's kind of do it this way, and oop, that's gone. That wasn't there. And they do ask you for the arc. This arc out here is not going to be 75. It will be 150. It is going to be double that angle. So because to get all the way out there, you do have to double it, because the central angle would be 150 if I wrote it in. So this arc would also be 150 in that case. Okay, so that's what they're saying. This angle is going to be half that arc. That's what they're saying. Okay, good question. So let's take a look at one. It says if EFG, so let's find that. Well, that would be this one, correct? Then determine EHG. Well, the first thing we should probably do is figure out if the two are even related. So there's the red, it's 80, that's the arc. So if I drew in this central angle, obviously this is a little off, but that would be 80, right? That's what the central angle would be. But what's the inscribed angle going to be? And do these work together? Is that the inscribed angle that makes that arc? It actually is. And so it has to be how much over here? It has to be 40. Okay? It's going to be half of it. Okay? So how about if I go HEF? Well, I better get rid of this stuff here. So HEF, where's that now? So HEF. EF. So that's the inscribed angle. I told you that was 96. So HGF. So does that arc and that inscribed angle, do they go together? Do they work together? Yes, they do. They are working together because it creates that one. So is this arc out here going to be 96? No? It's going to be how much? 192? Do we agree with 192? How'd you get 192? You took this number and doubled it. And is that 192? Yes, it is. So do you get the relationship between, really it's the relationship between the inscribed angle and the central angle, but we kind of look at the arcs normally. Okay? Any questions? Well, I have one. With that information then, sticking with the second example, could you tell me that one? Well, if 192 is used up, what's all the way around is 360, right? You would just subtract it, right? That's how you would figure that one out if you had to. And just checking with it, making sure you're awake. To some of you look like maybe you're not. Okay. So now it says if two inscribed angles of a circle or congruent circles, remember that statement's been coming up a lot, right? So we could have two circles sitting here that are the same, or we could have it just in one circle. I chose the one circle option. So they're saying if the inscribed angles are congruent, or they form the same arc, then the angles are going to be congruent. So let's take a look. It says that CBA, they say that angle is 90 degrees, so I'll just write it in there like that. It says first, let's determine that arc, because that's arc AEC, right? And what would that have to be? Sometimes you have to erase things in your mind, so maybe, you know, just kind of take those away in your mind, because I don't need that for right now. So if that's 90, what's that one got to be? Which means AEC is actually a semicircle, right? Okay. So this is 180 degrees. All right. Well, if this one over here is 180 degrees, that arc, now it's asking me to go find that angle. Does this angle create the exact same arc? Yeah, they hit here and they hit here, right? So if it creates the exact same arc, isn't that angle going to be the exact same as that one over there? Doesn't that make sense? And that's all this thing's saying. That if they make the same arc, they better have the same inscribed angle. So it is 90 degrees. If I were to connect points A and C with a segment, how could you describe that segment for me? If I were to connect points A and C based on the information given in this problem, how would you describe AC? It's obviously a chord, but I think we can do better than that. It'd be a diameter, wouldn't it? Would you correct that? This is 180. Is my picture perfect? No, but you got to follow the numbers. Okay. Any questions on inscribed so far? How you doing? You doing all right? Uh-oh, algebra. Well, that's saying that arc AC up there is 52 degrees, and down here it's saying angle B is 2x minus 4 degrees. Should I set these two equal to each other? Should they be the same? No. Do we know how they're related, though? Yeah. Basically, we know this one in here better be half of that, right? So what you can do if you want is actually just figure out what half of that is. And what is half of that? It's 26. So in here better be 26 degrees, right? That's what it should be numerically. Algebraically, it's 2x minus 4. So should 2x minus 4 and 26 be the same? They better be. We got to find the x value that's going to make that happen. So 2x minus 4 equals 26. Could I, if I wanted to, divide everything by 2 right now? Yeah, in fact, with this wouldn't even be the worst time to do that. There's a lot worse time to do that. But I'm going to just trying to give you those ideas. Let's just stick with the way you've been doing things. Let's add 4. So 2x equals 30, right? Now dividing by 2 is where you're used to doing that. X equals 15. If you put 15 back in, hopefully you get the 26, and it checks out that you do. So any questions on that one? So that wasn't too scary, right? Because angle ABC is what type of angle? What are we calling that? Inscribed, not central. This makes you blink a few times just to make sure you're seeing it right. Well, I see a 3x there, and I see an x plus 12. Any ideas? Oh, are they going to be equal? I heard somebody say set it equal to each other. Can somebody tell me why they would be equal? Well, because this angle is right here in red, and that inscribed is right there in green. Are they creating the same arc? So should they be the same? Do we know exactly what they are yet? No, but we know they better be the same when we're done, right? And so we do know, yes, that those better be the same because they are actually creating the exact same arc. Because let's say, I don't know this is right, but let's say we knew this was 20 down here, it would make both of those 10, wouldn't it? So look at it that way. Well, what's probably my best move first on this algebra? This one's a little different. Yeah, let's subtract that. Let's get those x's together. And I always like to move the smaller one too. So I have 3x minus x. That is 2x. Very good. I know earlier in this year people would tell me that that would be 3. And that's when I thought we might be in slight trouble. Divide by 2. X is 6. Okay. Could I then, in this problem, actually ask you to find arc EF? I could do that. How would you do that if I did ask that? I'll put 6 back in, right? So that angle right there is 18. That better be 18 over there as well, is it? If I put it in the other one? Yep. So this angle then, if I were to ask you, would be 36. Okay. So the central angle that creates that would also be 36. Again, you keep a central angle and inscribed straight in your head. That's really what you got to do. How we doing? Maybe one more. Oof. Well, that dot there in the middle is to tell you that's the center. In case you're wondering, that little dot in the middle is telling you it's the center. And so this would be a diameter, right? And this then has to be how much? Semicircle, so that has to be 180, right? Is this angle up here creating that semicircle? So that one in there has to be 90, right? Because if that's 180, it's got to be half that. So in this one, 4x minus 5 has to equal 90.